guys, so today we are going to start with SQL. So we have a lot of topics. If I talk about the introduction to SQL, so SQL is query language, and there are many databases using SQLite, MySQL, Postgres, Oracle, and everything, and they all support SQL. It's a relational database, and it helps users to query, manipulate, and transform data from a relational database. So if I ask about and tell about relational database is a representation of a table. So like similar to an Excel spreadsheet that you must have seen, it's like a table. So like you can see, this is a table about vehicles, like Ford Focus, the number of wheels, the number of doors, and the type. And in such a database, you can find additional related database. So by learning SQL, you can answer to questions about what type of vehicles on are on the road, which has less than four wheels and such things, right? So we'll start with the queries. The first query is select, and it is basically declares what kind of data we are looking for and where to find it, right? So you can think of a table in SQL as a type of entity, right? So each row is an instance of that type. So like a bug, a beagle, so it's an entity. And columns will represent the properties, the color, the length of the tail, right? So given the table, you can do like this, like select column from table. So you can select properties, whatever properties you want from any sort of table. And the result of this query will be like a 2D set of rows and columns, right? So if we retrieve absolutely all columns of data from table, if you want to retrieve all everything, then right select asterisk from my table. So using the asterisk and retrieve everything, right? So we will be using a database. So this is for example, like I'll try to explain you, like if you want the title of each film, this is a movie sort of table. And if I just want the title, these titles, I can just right select title from movies, right? And that is correct. Then if I just want the director, so for example this was the entire table, and if I just want the director, I can just write select director, right? And if I want title and director, so I can write title comma director. That will help me retrieve title and director. And if I want title and year of each film, I can write title comma year. And if I want everything, so I can just put an asterisk, right? So we did it. Let's just continue to the next. So the lesson 2 is if I have to add constraints. So you are selecting specific properties, specific columns, right? But if you had a table with like 100 millions of data, it would be impossible. So you add a filter, okay? That is why you add where clause, right? From that table you add a where clause. So where is applied to each row of data by checking specific column values to determine where it should apply, okay? So you can see that there are numerous and or logical keywords, right? So like the number of wheels should be greater than equals to 4 and door should be less than equals to 2, right? So these are the standard numerical operators. Then if you want range, you can say bit mean and. So column name should be between 1.5 and 10.5. And then not bit mean and, right? And then in like this list it should be, and then not, and it should not be in this list. So in addition to making results more manageable, writing clauses to constrain the set of rows returned also query to run faster due to the reduction in unnecessary data being returned. So as you might have noticed, SQL does not require you to write keywords all capitalized, but as a convention, it helps people distinguish SQL keywords from column and table names and make it easier. So you can write in small also, but you write like this, capitalized, so that you don't confuse, right? So like I want to find the movie with the row ID 6, that is this one, right? So how you will write? So you want obviously you want everything. So you want to find the movie, right? So movie It's just Incredibles. So I am just gonna select title from movies, where I will just write where ID equals 6, right? So you just select the title. If I select so select all the movies. If I just select everything, yeah, you can get everything about it, right? So now I have to select the movies in the years. So I'll just select everything. You can see here you have ID, title, director, in your year between 2004 to 2010, right? So I'll just select title, and where I'll just write year. So year is between. So you can see I told you, like, you can use this one. So year should be between 2000, and you can see you can use and, right? You can use in, not in, and. So 2000 and 2010. I'm sorry. So can we see? Yeah, this can do. And if it is not in this, so you can say not in 2000, not in 2000 and 2010. So not between, you can write not between, not in, not in. So if you write not between, that is going to be correct, right? Because what you want is that it should not be in this. Okay, not between 2000 and this. And now you want 5 Pixar movies in the release year. Okay, so you want 5 Pixar movies and the release year. So where title equals Pixar year. Okay, I just will see everything. Pixar, I don't see any Pixar. So we'll just see, select title and year from movies. Okay, Pixar is less than 2003, so you can use that. Less than equals to 2003. Okay, next. Now you have more constraints while writing where clause. SQL supports a lot of useful operators to do things like case insensitive string comparison, wildcard pattern matching. So you can see this. If you want case sensitive string, like column name ABC, you can do case sensitive exact string inequality comparison, you can do case insensitive, case insensitive like ABC, case insensitive exact string inequality, not like ABCD, used when the string to match a sequence, so like 80. So 80 here matching, 80 here matching, 80 is also matching. Used, so you can use percentage, right? Percentage here, like percentage 80, 80 anywhere. To match a single character only with a like, so and in the starting only, so there should be an. Then in, like in and not in that list. So for string you write apostrophe like this, right? So case sensitive means that ABCD, it should be like exactly ABCD. Insensitive, yeah. And you should know that most database implementations are quite efficient while using these operators. Full text search is best left to dedicated libraries like Apache, Linux, and Sphinx. These libraries are designed to do full text search and can support a wide variety of search filters, including internalization advanced queries. Okay, so for example, you want all the Toy Story movies. That is, yeah, you want all the. Okay, so we know about this. You use and like it percentage and this. Okay, just let's move on to the next. Filtering and sorting query results. So even though the data in the database can be unique, the results of particular query may not take a movies table, for example, may take different movies can be released in the same year. Such SQL provides convenient way to discard rows that have duplicate column value by using distinct keyword. So you don't want duplicacy, right? So distinct can will remove duplicate rows. We will learn in future lesson how to discard duplicates based on a specific column using grouping and group by clause, right? So filtering and sorting. So you can see if I want to order, unlike neatly ordered table in last few, in real database there's no order. Okay, so you order by. So see where condition you order by ascending or descending. So each row is sorted alphanumerically based on specific column value. In some database, you can sort data using international text. Okay. Then if you want to limit, so order by clause are used. So with order by, this is used a lot. Limit and offset. So limit will reduce the number of rows to return, and optional offset will specify where to begin counting the number of rows from. If you think about websites like Reddit or Pinterest, the front page is a list of links sorted by popularity and time. And each subsequent page can be represented by a set of links at different offsets in the table. Like so, using these clauses, the database can execute queries faster, more efficiently by processing and returning only the requested content. If you're curious about limit and offset, you can see this. Okay, so limit and then offset. So if So when you open Reddit or Pinterest, the front page is set of links sorted by popularity and time, and the subsequent page can be presented by the set of links of different offsets. So after order by column, whatever column like order by column of title or anything ascending, descending, or like ID ascending, you can do this. Okay, just see the simple select. So you have a basic idea, right? How to write select queries. So these are some questions of select queries. We just see gonna see joins is very important. So up to now you work on a single table, so it's often broke in real world into different pieces, and that is different tables, and that is called normalization. Because it is used because we want to minimize the duplicate data in single table. Obviously you say that, oh, but we just studied about using distinct keyword, but still, to minimize duplicacy, you divide the table into multiple. And as a trade-off, queries get a little complex because you want data from different tables, and performance issues can arise. So in order to answer questions about entity as a data spanning multiple tables, you write with the joins, right? So tables that share information about single entity need to have primary key that identifies that table uniquely across the database. One common primary key is auto incrementing integer. It can be a string hash value. It should be just unique and not null, right? So using the join clause, we can combine raw data across two separate table using this unique key. So we are studying about inner join first. So you can see like you have written select query from the table, and then you've written inner join, and then you have written the where clause afterwards in order by limit. So inner join another table on my table ID is equals to another table ID. So you can see you use on, right? You use inner join on. So inner join another table. Okay, to create a resulted row, and with the combined columns from both the tables. So ID column, so both tables combined column, right? So yeah, I'll just show you guys uh, joins in SQL. So I'm just going to show you some images so you can see this image. So this is, where is the inner join? If I just see, actually these are the different joins. Yeah, you can see inner join is like common, the common in both. Left is left and right is right, and full has both, but inner is common in both, right? So let's join, see. Yeah, so you can see this selects all rows from the table as long as the condition is satisfied. The keyword will create the result set by combining all rows from both the table with the condition satisfies, right? So you see, this is the student table, roll number, name, address, phone number, age. This is student course table. So if we apply inner join, the roll number in the student table and student course roll number should be equal, right? So 1, 2, 3 and 1, 2, 3. So Harsh, Pratik and Priyanka. We want just these three things. We're selecting this from the student. We're doing from the student and inner join on student course, right? You can see left join also. So you can use left outer join on left join, both same. So all rows from left table along with matching rows from right table, right? Here was selects all rows from both the table as long as the condition is satisfied. Create a result set by combining all rows from both the tables where the condition satisfies. And what is the condition? The common will be same. Common value will be same. Like, okay, all rows it selects. And here only the left, only rows from the left row and the matching from the right. Matching rows from the right. So you can see again we have, we apply this, so we get this. So from student, inner join or left join the student course table on student roll number, and okay, so 1, 2, 3 and 1, 2, 3. What is the output that we're getting on left join? So we're doing left join of this so 4, 5 is not present, right? So we write, what we do in 4, 5 is null. We just write null. We don't write 4, 5, we write null. So the matching and all the left. So student table and student course. This is the table 1 and this is the table 2. It takes everything from the student one. All these names we take. And besides that, there will be null because there is no matching. Again, for the right join, we take all the left ones, right ones actually, sorry, right ones and the matching left ones. Right side will join, matching rows from, and the left side will join. Similar to the left join for the rows, for there is no matching, right? So you can say right outer join also. You can see full join. Full join has both, combining both left and right. So if there is nothing, then there is a null. So full join, and then there's a natural join, which is inner join, which joins two tables based on columns with the same name and data type. It returns only the rows where the values in the common values match, right? Unlike cross join, which creates all possible, a natural join will only include rows with matching rows. Cross join will include everything. So we basic is inner join, left join, and right join. Right? We just see this is the same thing. We're gonna see more. Okay, so this is outer join. So depending on how you want to analyze the data, the inner join might not be sufficient. You have to use it has asymmetric. You have to use right or full as both together, A and B. Okay, so we'll just see this one. So uh, it's always good to reduce the possibility of null values in database because they require special attention, right? So alternative to null is to have data type appropriate default values, like zero for numerical, empty for text data. But if your database needs to store incomplete data, then null can be appropriate. Okay. Sometimes it's not possible to avoid null cases, as we saw in last lesson when outer joining two tables with asymmetric data. In these cases, you can test a column for null values in where clause, right? Is null or is not null constraint. Where column is null or is not null. I hope you are getting this one. Yeah, now this. Okay. So when you have a mathematical operation, you can do this absolute, right? I think this is not that important. These are aggregates. So aggregates allows to summarize information about a group of rows. With the Pixel database that you have been using, aggregate can answer a question like how many movies has Pixel produced, highest crossing film. So you apply constraint after where constraint group by column, right? So where so you have count otherwise count the number of rows in the group with no null values, right? Count everything, minimum, maximum, average, sum, right? These are aggregate functions. Without a specific grouping, each aggregate function is going to run the whole set of rows. Unlike normal expressions give you aggregate function, and alias ensures the result is GD request. So group by addition to aggregating, you can instead apply the aggregate function in individual groups of data like box office sales for comedy and group by. So you select aggregate function as aggregate. Okay, you write here the aggregate function, select count everything, right, and group by column. Okay, then you have having also. So having clause, so SQL allows adding having clause, which is specifically with the use by with the group by clause to allow us filter group data from. So having clause is written the same way as where. So you if you aren't using the group by clause, simply use where clause, right? Like having this, so like a particular useful construct, being able to apply additional constraints often. Okay, make sense of data, right? So you can see we use select distinct whatever column aggregate function, then from this table you can apply join, like inner join anything on you, right? You apply where you have a constraint, you use group by, and if there is group by then you use having, and last but not the least you use order by this, you know, you order sort it out, and then limit, you can set limit and offset together, right? So you can see that from clause and join is there. This includes subqueries in this clause and can cause temporary tables to be created on the hood containing all the columns and rows to be joined. Once we used working set of data, the first pass where constraint is applied to individual rows, and rows that do not satisfy are discarded. Each of these constraints can only access columns directly from the tables requested in the form clause. Aliases in the select part of the query is not accessible in most databases since they are made expressions independent. Okay, so group by, you know that group by is the remaining rows after the where is then grouped on basis of column common values in the column, and as a result of grouping there will be only as many rows as their unique values in the column. Okay, implicitly this means that you should need not use this. You only need to use this when you have aggregate functions. Okay, group by is when aggregate, and if there's group by you use having, right? Then the constraint having are then applied to group rows. Discard the group row that does not satisfy, like the where clause aliases are also not accessible from this step. So where from where also is not acceptable. If you're wondering what this aliases is an alternative shorter term as nickname given to longer commands. Right? You can't write where and then write as blah blah blah. No. Select. You have to select distinct. You don't want the duplicate thing. Duplicate values, rows with duplicate values you don't want. Rows with duplicate values you don't want. And if an order is there, you use order by to specify the order. Right? Limit and offset, you can see you set the range. If the rows are set the range limited by limit and offset, they are discarded. Right? So you got it right. Basically this is important. Select distinct, apply the aggregate if you want from, and then you apply join. This is where you write where this is the constraint. Then group by and having together, and you order it by ascending, descending, and limit. And what else? Offset, right? You can update this, add, update table, set, and where. So similar to insert, you can update. I don't think so update is that important. Delete data from database, you can delete, which describes the table to act on. Like you can just delete. Yeah. Then you can create table if not exists. Okay. Create table, movies, id, integer, primary key, title, this, right? You write id, then the data type, and then id, data type, and whatever the constraint is, like primary key and all. These are the constraint: primary key, auto increment, unique, foreign key, right? And these are the data types, right? Blob is what? Finally, SQL for showing stored binary data in blobs. These values are often opaque in the database, so you have to store them in the right metadata. Blob. Yeah, sure. Then altering tables. So if you want to alter table, my tables, alter my table, and then add column this default value, right? This is altering the statement to add, remove, or the syntax for adding new column is this. Dropping is easy. Drop. Okay, so if for example you want to drop, in some rare cases you want to remove an entire table including all its data, metadata, you can use a drop table, which differs from delete in that it also removes the table schema from the database entirely. So delete will improve the schema also. Table only, not schema also. You want to drop data, you have to drop the data and metadata from drop, right? But it does not delete the schema. Like the create table, the database may throw an error. If the table does not express the error, you can use if exist clause. So if it exists, if you have another like foreign key dependency, then you have to either update all the dependent tables and then remove the dependent rows, right? So yeah, pretty much that's it. we we know the basics very much. We know this order table and add whatever column we want, data type, id, primary key, whatever. Then you can update, set values, and then where. Yeah, we know about this also. Cool. Do we have more topics? We have subqueries. Query, you write query, and inside a query you write another query. So there are many questions we can't answer, so you add a more query, right? Okay, fine. And what else do we have? Apart from subquerying, we have union, union all, intersect. And okay, so while working with multiple tables, Union and union all operator allows you to append data of one query to another, assuming that they have same column count, order, and data type. If you use union without all, duplicate rows between the table will be removed from the in order of okay. So order of execution, the union happens before order by element, right? But if you have data in different tables that cannot be joined, you have alternative to make multiple. Similar to union, the intersect operator will ensure only rows that are identical, and the except operator will ensure the first result set aren't in the second. This means except operator is query order sets, like the left join and right join, right? Both intersect and except discard duplicate rows after the respective operations through some databases. Also support intersect all and except all to allow duplicates to be returned. Union all. Union allows you to append data of one query to assuming that they have same column count. Union without the all duplicate rows between will so union will have no duplicate rows. Union all will have duplicate rows. Intersect only the common ones except removing except. So then you write select this from this table, and then this, right? Cool enough. I think this is cool enough. What we are going to another search is that um yeah, that's it, I guess. We don't have much.